Alright, Bismillahirrahmanirrahim. We have another machine problem, okay, from the structural analysis chapter of ours. They says that using a chain and pulley mechanical system, okay, how much force is required to lift a block of weight W is equals to 200 newtons, okay, and you need to also calculate the mechanical advantage of this machine. So this machine you have to calculate the mechanical advantage, okay. So if you look at it in this kind of a numerical, we have to select first of all our respective frame of reference from where we'll start, okay. So if you look at it, this is our basically these are the three pulleys, okay, and we will going to neglect the weight of the pulleys and we'll assume that this chain which is passing through from starting from A, passing through B to C and reaching this point D, this is one chain, okay. And then we have another chain, basically if you look at it, which is starting from F, passing to point E, and from here it goes to G, and from G it goes to H, and from H it goes to I, and from here it basically reaches to the person who's basically trying to pull it towards himself, and he wants to lift this load of 200 Newton, okay. So if you want, we can basically very easily solve this problem basically by considering our initial point, okay. If you look at it, what is going to be our initial point, that is what we want. So here what we can do is, the first thing is that we can assume that say that there is basically tension here. If you look at it, there is going to be tension here. We say this is tension T, and starting from here it will also have the same tension here, okay. This tension is also going to be T, okay. This tension is also going to be T, okay. We will assume it as this is also as T. This tension is also T, and you know the weight is acting downwards. This weight is acting downwards, okay. So this weight is acting downwards. This weight is acting downwards, okay, here. So if you just consider this free body diagram of the total system as this, if you just consider this one, okay, only this segment. So, and you know this is your y-axis is going to be, this is, you know, this is going to be your y-axis, and this is going to be your x-axis, plus x, and this is going to be your plus y, remember. So just apply sigma Fi on this system, okay. If you look at it, you will have one tension force here and you have another tension force which is T, okay, remember this is T. So if you can apply sigma Fy is equal to 0. So if you look at it, there the two T's are acting towards the positive y, so you can see 2T towards the positive y, the weight is acting downwards, minus W is equal to 0. So you can say 2T is equals to W. So 2T is equals to, what is W? 200, okay. So you get the value of T equals to 100 Newton, okay. So this is very important. You have got T equals to 100 Newton. Once this is done, you can go to the other part of your diagram. If you look at it, if you go here, now you know this has basically this chain has ended here, okay. And you know this is another chain. This is another chain which is going from here and then passing from here to here until it's reaching point F. So the tension what is here in this chain which was T equals to 100 Newton, is not going to be in this chain. It is some different tension. So we can assume that tension in this chain is say this is T1. If this is T1, the tension here will also be, we can say, is going to be T1, and if the tension is here in T1, it's also at this point it is also going to be equals to T1. Okay, and remember that T is not equal to T1. Okay, we don't know what it is. Okay, so what we can do here is basically, if you look at this system, okay, if you look at this system, we can easily say that our you can say our FBD somewhere here. If you look at it and we draw just this, consider this system from here. Okay, just wait me. We just consider this system. Okay, we just consider this system. Okay, if we consider this system here, okay, and you know it very well that if you look at it, this is our pulley, and if you want, we can say there is one force going in this direction, another force is going in this direction, and you know this is also, this was different, you can say this is like this. Okay, so you know this is T1, this is T1, and this was calculated as T. Okay, and you can just apply, and you know T was how much? 100 Newton. T was how much? T was 100 Newton. Remember, 100 Newton. So you again apply. If you look at it, you can apply sigma Fy is equal to 0. If you apply sigma Fy equal to 0 again, so you can see this is T1 plus T1. Okay, and this is towards the negative y. Okay, so minus T is equal to 0. So you can say 2 times of T1 is equals to T. So you can say 2 times of T1 is equals to, how much was T that we calculated? 100. Okay, T1 was 100. So from here you can calculate your T1 comes out to be equals to 50 Newton. If you look at it, and this is your T1. Okay, this is your T1. So you can see T1 equals to 50 Newton. So the person who is standing here, okay, the person who is standing here, okay, this person, when he is trying to apply the force here, okay, when he is trying to apply the force here, in order to lift this basically chain downwards, okay, so he will be applying a 50 Newton force, and he is going to get an output as, basically this is input was 50 Newton, and he is basically lifting a load of 200 Newton. So you can say what is going to be the mechanical advantage. Mechanical advantage will be, you can easily say, is basically 200 divided by, you can easily say mechanical advantage is going to be 200 divided by 50. 200 divided by 50. So it comes out to be equals to 4:1. So this is the mechanical advantage. This is the mechanical advantage of this system. So it's an easy problem, but you should be able to gain some concepts, fundamental concepts, how chain and pulley mechanical systems are solved. I have done one more problem in the class also, whose video is also available. If you look at it, here this problem. Okay, remember, you can, this is a more difficult problem. If you do the from this problem, you'll be able to understand much better differential chain cable force analysis. Okay, so remember this thing. So this is, I hope you have understood it, the concept of how chain and pulley mechanical system machines, basically these are machines, are basically being solved in statics. So I hope you have understood it. Thank you very much, students. I shall be doing more problems of machines, more typical one after this one. Thank you.